Good morning and good day to everybody from all over the world. Welcome back to the CIB Presidential Seminar Series that we broadcast from Purdue University. And as you all know, the theme for this semester is leading researchers and regional directors from all around the world. As we had discussed before, CIB has several regions or around the world. The membership comes from 55 different countries. And this semester, we have been inviting the regional directors and top academics from around the world to share their research and what is happening in their part of the world. So again, today, it is indeed my pleasure to introduce our speaker today. That's Professor Dongping Fang from Tsinghua University in Beijing, China. Let me quickly go over his illustrious CV. I may not be able to cover everything, but I'll give you a good snapshot of his achievements. So Professor Fang is the Dean and Professor of the School of Civil Engineering at Tsinghua University in Beijing, China. He also serves as the Deputy Director of the Institute for Future Cities and Infrastructures. Professor Fang specializes in safety in construction and urban resilience. He developed a cognition-based leadership culture behavior LCB approach for construction safety and a trio space framework for physical cyber societal system for urban resilience. Currently, his research focuses on human-centric approaches to improve urban resilience against earthquakes and floods. Professor Fang has authored over 200 papers in peer-reviewed academic journals and has been recognized as a highly cited Chinese researcher by Elsevier for 10 consecutive years. He has been invited as keynote speaker at more than 50 international conferences, such as the World Building Congress 2016 and 2022, and Urban Transitions in 2017. His contributions have earned him awards from the Construction Industry Institute in Hong Kong and the Chartered Institute of Building, CIOB, in the UK. From 2010 to 2013, he was the board member of the International Council for Research and Innovation in Building and Construction, CIB, and the chair of its program committee from 2013 to 16. He was the vice president of CIB, and he currently serves as the member of the board and its program committee. He also serves as co-president of the International Consortium of Construction Engineering and Project Management, the ICC-EPM, and vice chair of the Special Committee of the China Construction Industry Association. So with that said, please welcome Professor Fang. Dumpling, over to you.
Okay, thank you, Mark, for your kind introduction. Good evening, good morning, and good day, ladies and gentlemen. Can you hear and see the screen?
Yes.
So it should be good, right? Okay.
Yeah.
Today, I think I divide the presentation into two parts. The first part is the so-called people-centric approach for improving urban resilience. It's an area focused by a group of professors and students in my school. I get to introduce what we have done in this field. And the second part is a brief introduction of several CIB members in Great China of their research activities in recent years. So let me start from the first part. Sorry, this is the outline. Let me start from the background. We work on urban resilience because the urbanization was the world trend in the past and will continue in the future. You can see the progress of urbanization in the past and in the future by the maps here. And as for China, 70% of the cities and the 50% of Chinese people are located in natural disaster-prone areas. Earthquake, flooding, and lots of the geological hazards. And to avoid this kind of disturbance by natural hazards, even by the man-made hazards, the concept of resilience comes out. There's different understandings of resilience by different people. So I listed some of the definitions of the resilience. You can see, I don't want to repeat one by one, but you can see from different fields, they define resilience quite differently. But as for urban resilience, there are also various kinds of the definitions. So I listed several very famous ones. I made some of the keywords in red. So yeah, there's a lot of the repeated words that is very important in the concept of urban resilience. So there, as for the keywords in terms of resilience, we have the ability as the description of resilience. So it's defined as kind of the intrinsic property of a system. The system can be an urban system, can be an infrastructure system, so as much as you can define. And function or functionality is another keyword that describes the goal and provide a measurement for the goal that could be reached. So I explain a little bit later. And disturbance specifies to the context or type of disasters, such as flood or earthquake. The context can be very different because of the disasters. And resist and absorb is another keyword that stands for the when disturbance comes, the system is able to resist or absorb the negative impact by itself. So by itself is a very, very important concept because we differentiate from the outside aid. And recover, I would define it as the most important word for the resilience. So it can be understood like the system is able to recover from the negative impacts to some desired function. So the desired is another keyword because I'll explain later on. It's very important for resilience and adapt and transform. The system is able to learn and self-organize for future disturbance. It means a learning process to make the urban system more adaptive. Okay, so it brought out a few questions. First, as for the ability, then what's the boundary of a system? As I mentioned, by itself in the resist I just mentioned. So we need a boundary to define itself. So it's always a very important question to answer for what is the boundary of your system. And the second, resilience for whom? So it means the goal. For people or for any functionalities of a system. So I use the name people-centric, indicates that in our study, we make the resilience for people. And resilience for what? to what? It refers to the different disasters, the earthquake, flood, hurricane, or various kinds of the disasters. So then, as for recover, it's related to how long is this time span of interest. So the recover can be forever after disaster, especially for large major disasters. And then how to define desired functionality of a city. I'll answer all these questions alongside with my presentation later on. So to make it more understandable, I use this figure to show you how to quantify urban resilience and how to understand improving urban resilience. So if you look at the blue curve here in this figure, you will see after a shock, then the curve will drop down. That means we lost the functionality of our system. As I mentioned, the system can be a power supply system, can be a water supply, and it can be the whole city's functionality. So the aim for us to improve or upgrade our resilience, it means we need to move the blue curve to the red curve. So it means in every stages of the resilience or the cycle of the resilience, we need to improve its functionality because functionality means the city's services to people, to the operation of the whole city. So this is our ways to understand our cities. Different people may understand cities in very different way. Engineers has their perspective. Sociologists has their own perspective. And the citizens has their understanding about their cities. But our understanding is that in the bottom, the physical infrastructure supports social services, that's the middle layer, to meet the people's needs, that's the top layer. So this is the three-layer understanding of our cities by at least my team. We work together based on this understanding. And then there's another perspective called system of systems for understanding our cities. So, you know, in a city, all the systems, different kind of systems, has their role or functionality to serve the country, to serve the city. And they are all interdependent to some extent. So this is the figure to show you how they interdependent. And let we change to another perspective. That is what I call trail space. That means we as an engineer pay much more attention on physical spaces. It's related to natural environment and our built environment. It's all physical. But the city exists because of people living there. So the societal space is an unneglectable part of the city. So I call it the social space. And in the modern life, cyber is the must for all the citizens. So cyberspace is another one. So it refers to the digital mapping to reflect the status of physical and societal spaces. The digital twin refers to this. But the cyberspace also supported the communication and operation of physical and societal spaces. So it's easy to understand because we all live in the city. So I showed you several kind of the angles to understand cities. So I'm trying to make the three perspectives together. First, put the system of system into the trail space. So we can have such a view of our cities. We call it the system of system in trail space. Well, this is the brief introduction of the understanding of the background of urban resilience. Then the methodologies we used to make research on this area is as follows. So I started with two critical questions. First, how the effects of natural hazards spread across different engineering systems, that means the physical systems, and across both physical and social dimensions. It means across physical to social dimensions and what's vital. This is the first question. And the second, how to better use the limited resources. So I emphasized the limited resources because no cities, no local government has, even the national government has sufficient resources for resilience. So the resources are always limited. So how to use the limited resources to improve urban resilience in an effective way? Because it's always the matter that the cities put resources to improve their safety and resilience, but may not be in a very optimized or effective way. This is what we are trying to contribute to the urban life. Okay, you can see in this figure, you can also see the interdependencies, both physical and geographical, production interdependence, and the functional interdependence. So we are facing with a very complicated system. So now the question is how to tackle with this kind of the complicated issues. First, a cross-system scenario deduction approach based on federation architecture and co-simulation of different physical infrastructures was developed by our team, try to achieve a collaborative analysis of disaster response in interdependent heterogeneous infrastructure systems, such as power supply and drainage. This is an example we studied in a certain city. You can see if we consider the cross-system interdependencies, the resilience curve can be different. So it means considering the cross-system interdependencies is very, very important. But it's also, again, still limited in physical space. So the second approach was developed, that's the cross-dimensional scenario deduction approach. That is to model the propagation of the disasters from physical space to societal space. That is the cross-dimensional. We used the area models to study the loss and recovery process of social infrastructures. So we looked at the influence to economy, influence on mobility, and influence on healthcare systems. And we also developed the methodologies to optimize and enhancing the urban resilience. Optimizing means we try to allocate the critical infrastructure so that the major investment can be allocated to this kind of the so-called critical infrastructures. We use the biased page rank algorithm to identify the we call it the critical infrastructure, and we also use the multiple choice knapsack algorithm to allocate the resources, limited resources, to the right critical infrastructures. So this is about the methodology part. So then come to the people-centric. Look at the left figure. I actually fold the model I expressed before into such a sandwich. Then we have people inside in the middle. So that's why we call people-centric. So if you see this model, you will find that all the needs or all the functionalities actually can be defined by the people's needs or the quality of life that people live after a disaster. So we try to develop a model for build an index system so that the people's needs can be quantified. So this is the quantified the index for people's needs. Actually, this is based on a huge amount of the survey and the data statistics analysis to group all the needs into several indexes. Now we have 39 indexes all together to represent the functionality of the urban systems. So here, based on the previous methodology, in case we have a disaster case, we can have such two curves in the left. One is the actual performance of the system, of the whole urban system, and the light blue one on it was called the expected performance or desired performance. That is what the people want after, or if you give them, they can be satisfied. So we call it the desired or the expected. So with regard to the resilience, this is actually in the lower part of the figure. You can see the formula that R equals to two integrations. That is the two areas of the two curves. So the ratio of the two areas represents the resilience. So the resilience is the value from 0 to 1. So in the right hand, the curves represent a case study based in the Wenchuan earthquake happened in 2008. We revisited the whole performance. We have the blue curve, and we have the red one. That is, we simulated if the same earthquake happened right now. What's the performance of the urban system, the whole city? And the dot red curve represents the desired or the expected performance. So it means we don't expect the the quality of life or the urban performance recovered back to the normal in one day. But because the citizens are not don't expect they can do everything after major disaster. So their expectations are also lower. So this is the concept we brought to the resilience because we think this is the right way to calculate the resilience. Okay, and on top of this, we also try to use the hypernetwork to model the complexity of the interconnected systems and events. We use this is the methodology come from the graph theory. The graph theory, the hypernetwork was developed from graph theory. We use hypernetwork for modeling our urban performance. So I don't have time to go to details, but I just try to brief you that there's a few very important the index in the hypernetwork that can represent the performance of our urban systems. For example, the hyper edge, that is one of the KPI in hypernetwork, can reflect the dynamics of the quality of life of citizens. So that is related to the indexes we developed to measure the urban functionality. Okay, I briefly introduced the methodology we used. It's not only one methodology, it's a series of the methodologies. So I get to show you two cases. We used what we developed to look at the real cities. One is in Mianzhu. It is one of the city that was heavily attacked by the Wenchuan earthquake for 16 years ago. So we investigated all its urban systems, and we developed the models for power supply, for water drainage, so that we can connect them into a physical system and networks, so that all the interdependencies of the two systems can be simulated like this. You can see the functionality of power and the functionality of water is closely correlated, and their recovery process can be different. It's all related to the interdependence of the two systems. So we use this kind of methodology to identify the key problems within our urban physical infrastructures. And we also look at the healthcare systems. We choose the several hospitals and looked at the per hospital rescue process. So based on the agent and the model and the system dynamics model, we developed such an simulation tool that can represent how the injured could be rescued and sent to the hospital, and the capability of this task can be represented by the resilience curve below. So we also looked at the impact to the local economic systems. So again, the industrial daily output and the retail daily output was presented here. It's all based on our simulation from the earthquake input, from the structural failure, to the damage to the industry output and retail output. since the limited time is limited, so I could not go to any details. Okay, and sum them to all these functionalities together, and based on our indexes for the human needs, or we call it the quality of life, based on the indicators, we can have such a curve. That is the actual performance. Of course, it's simulated because there's no earthquake happened today, but we used all the current infrastructure and the urban information, but based on the input of 16 years ago. So we can see the gap between the desired performance and the actual performance. So this is the gap we should pay attention to. And this is also the gap for resilience. So based on all this kind of simulations, we start to identify the critical infrastructures back to the case I expressed. So here the star was identified as the critical infrastructure, and then we developed different strategies to invest to these critical infrastructures. And you will see different strategies may result in different resilience curve. It means we use this methodology, we can choose the best strategies. We represented two, but there should be many, so that we can use this for pre-disaster preparation for better resilience. The second case is happening in Beijing. It's a rainstorm in the past few years. So we have two areas that was suffered with the rainstorm caused flooding. Again, we use the same indexes, and based on the data we collected from the platform that is used to take the claims from the citizen. For example, they don't have water, they don't have signals, and so on. So this is a very effective platform for serve the citizen in Beijing. And this is also a good data bank for us to analyze all the details of the city performance. Here, the curve we collected from the during the rainstorm, you can see the needs increase. It means the drop curve means the satisfaction goes down. It means more needs are not met by the city services. So this is the summarized curve for the different level of needs. So back to here, we divided the needs into three layers: survival and safety needs. That's the fundamental. So here you can see it recovered better, quicker, because that is the must. So the government paid more attention on. So I skip some. So we compared our modeling with the real problems happen in Beijing. So we tried to compare if our methodology is correct or not. We found basically it's in the same trends, but there's always some gaps between the two. This is the key. We are now looking at how it means, what it means. So we also use the hypernetwork model to decode the resilience curves. We have only a curve, but we need to know the details, why it goes down or why it goes out. How can we make it goes up quicker. This is depends on the hyper network analysis. So a little bit details about how this indexes was used by us to analyze all the details of the causations of this functionality drop. So I don't think I have time to go details. In the end, one of the result we can provide is this kind of a map. So we divided the area into about 800 communities, and we can indicate the levels of the resilience, the residents perceived in different community, so that this may indicate to the government that where they should invest. It's also related to the equality of the citizens during the disaster. So we are still explore and discover more indexes from this methodology, so that more detailed use of these indicators can be discovered and put into practice. So we, based on this method, the researches, we involved in the policy making of the Beijing metropolitan government. We also helped to evaluate the resilience of the Beijing Olympic facilities and residents. Okay, in conclusion, a quantitative human-centric or people-centric framework was proposed to assess urban resilience by tracking dynamic and hierarchical needs of residents after disaster. This is one of the things we've done. Second, a cross-system and cross-dimensional approach was proposed based on the scenario simulation and deduction to describe the diffusion of post-disaster losses, how the losses spread out, and which enabled the identification of key infrastructure and better allocation of limited resources for quick recovery. So all the cities suffered with disasters may recover, but we want it recover quicker, because recover quicker means the citizen's life could be come to normal quicker, and the economy of the city can be recovered quickly, so that the citizens can have much less loss and a better life in the future. Third, a multi-layer hyper-network model was developed to analyze the post-disaster recovery process based on the hyper-edge evolution. And this model is able to review the urban disaster dynamics and recovery patterns to facilitate the development of effective post-disaster recovery strategies. This is the thing we haven't finished. We are still working on that, because we found there's a huge potential to have more detailed indications from this study. And fourth, these approaches were used to revisit the 2008 earthquake in Mianzhu and the 2023 extreme rainstorm in Beijing. This is 2 case studies. We try to explore better ways for efficient improvement of urban resilience. So this is the work we have done in this area, but many of them has not been finished. It's all on the way. So I hope the audience may also raise questions, if not today, later on by emails, so that we can further improve this methodology. Okay, thank you. And this is the work by a team of our faculty and students. Dr. Nan Li, Dr. Zaishang Li is the key member in this team. Okay, I think I need to go quickly for the second part. Mark, is that okay for our members' activities? Or I need to stop for questions? Okay, so as for the CIB members' research activities, I specified into three members. The first is the Shanghai Research Institute of Building Science Group. This organization is the full member of CIB for many, many years. It's based in Shanghai. And the second is also I think it's associate member, the Department of Building and Real Estate in the Hong Kong Polytechnic University. This is listed the three members of CIB. So I just quickly, because the time is run over, so I just try to quickly to show you. But I think the slides also can be shared. But I just quickly show you what happened in the Shanghai Research Institute for Building. It established about 60 years ago and focused on the green and low carbon development, urban maintenance, and organic renewal and comprehensive digital transformation. So then I think the introduction can be long, but I try to go to, sorry, what's wrong? So this is what the outcome of the institute, but a few slides about how they what's the achievement they have in this area. First, green building and carbon neutrality. They did do a lot for the industry. And then operation and renovation in the city. Most of their services within Shanghai. You know, Shanghai is a major mega city, so there's a huge needs for test, evaluation, assessment, maintenance, and renovation for in-use buildings, bridges, tunnels. This is a big issue now in China. And they have smart city related researches. And the typical service cases, you can see now they do a lot in Shanghai, but they also do projects in Beijing and even in Haifa, Israel, and Cambodia, and so on, a few projects. So they try to be an international institute in this field. And second slide, second part is about the Hong Kong Polytechnic University. It's very limited slides. They just try to represent some of the typical technologies for vision-based monitoring of outdoor workers. This is a big issue in our industry. And they also do the work task recognition and productivity analysis. So this is about productivity. And you know, now it's very popular for the MIC. It's the modular integration and construction. It means the precasted elements was transported to the site, and they just install it in the site. So MIC now is very popular in Hong Kong and in mainland China. So it also initiated lots of the studies for these technologies. Now the 17th floor tower can be built by the MIC. And the optimization of the site layout is another one that conducted in Hong Kong PolyU. Because in Hong Kong, the site is very, very narrow. So the site layout is very, very important. And this is all about the site layout. And extended reality-based teleoperated tower crane. This is also a challenge now, but many groups are looking at this one because if it is realized, there's a big increase of the productivity and safety as well. And dynamic information processing and visualization is also for the construction site. So it's their research is quite advanced in this area. And 3D printing in construction. Lots of new technologies and capabilities can be developed based on the 3D. Okay, then come back to my school. We have a group of faculties working on construction safety, safety and health risk monitoring assessment, and early warning based on the intelligent technologies has developed. This work and human-machine interaction, safety management. This is mainly done by the Hongling Guo's group and my group. We work together on this. And the construction site IoT platform. This is in a huge demand in China. So we do a lot for the construction companies, and it's quite well welcomed. So a few projects has been implemented with our technologies. And this is the case in Qingdao, is in another city. That is the wool in your eye and the hazards in environment. It's a tool for the managers to identify the hazards by the advanced technology. This is conducted by Dr. Bin Chao. And this is a lift path planning. We have conducted. This is mainly done by Dr. Guo in Hong Kong. We developed the lift path planning for improving the productivities of the crane and the concrete casting. And carbon emission is another part that we have a group of people to work on. And quite a few national standard was developed to try to enforce the industry to decrease their carbon emission. Okay, this is the very brief summary of the three members' work in this field. So I would like to end my presentation today, but I think the time is already a few minutes past the time limit. So Mark, is there any questions I should answer?
Yeah, of course. No, thank you, Professor Fang. That was a very nice presentation, and thanks for covering a broad area, starting with resilience in urban environments to the work that is being done by three very prominent CIB members in that region. Indeed, a lot to cover. So we still have a few minutes. We can take question and answers if that is okay. By the way, everybody should know that the time in Beijing presently or in China is 12:30 a.m. in the morning. So thanks to Professor Fang that he has stayed up.
Okay.
So please open your mics, and if you have any question, I cannot see everybody's hand, but go ahead, please. Anybody? All right, well, start thinking about your questions, and let me start with mine. And so, Dongping, you mentioned, first of all, a very nice presentation, and a lot of area and research that you're doing is very, very interesting. As you know, we have a big group working in that space here as well at Purdue. And so when you visit next time, we'll share some of those results with you as well. But what has come up again and again is the definition of resilience. And you brought that up also earlier in your presentation, that there are a lot of different definitions of resilience being used, some of them right and some of them questionable. So I was wondering in your research, what has been your thought in what should be that definition of resilience that fits best for urban environments?
Okay, thank you for the question. So in order to answer your question, I think I need to go back to one of the slides. I get to share you again. Okay, verbally, the last definition is our definition. Is the urban resilience is defined as the ability of an urban system and all its constituent subsystems to maintain the necessary functions during disturbance, rapidly recover in the aftermath of the disturbance, and adapt to uncertainties in the future. This is
Okay.
actually represented here in this curve. This is represented what we understood as urban
Yeah, no, very, very
resilience.
nice. Yeah,
I
I
cannot
think
say I'm correct, but we believed in it.
no, I think that is quite important, right? I mean, that is the basis of how we all position ourselves in terms of what that resilience should be. So I quite agree with the definition that you proposed. Um, I see that Dave has put a question in the chat, and he says, for research in China at universities, what are the primary sources of funding?
Okay, good question. And it's an easy question for me. So thanks for your interest. I think the Chinese universities has resources from several parties. First is the National Science Foundation of China. This is the major and the high-profile foundations for the Chinese universities. The second is from the Ministry of Science and Technology. And this ministry always try to organize the research projects, something like the 2 or 3 million US dollar or above. So for that kind of projects, we need to group not only one universities, maybe a few universities to group together to apply for. And another source is from the industry. Now there's a huge demand from the industry for researches. So the Chinese universities has a quite good timing to do research for the industry. The industry research is more practical, but in many cases, in the end, it's related to the more scientific issues related to the National Science Foundation. As for myself, most of my research ideas came from the industry. They came to me for the practical questions, and then they found me to do research for them practically. And after I did it for them, I always, in many cases, I found the research could go more depth to science and technologies. So then I applied for the fund from the NSFC, the National Science Foundation of China, so that I can connect my research from practice to theoretical to theories, so that that can be linked to a bigger project that may, again, we can make it a bigger idea for the bigger projects. So this is what we do in Chinese universities.
Thank you, Dave. That was a good question. Any other questions from our audience? You can either put it in the chat or you can ask a question. Yes, go ahead.
Professor Fang, my name is Wei Zhou, and I'm studying a PhD student in Purdue. And thank you for your very nice presentation. As a Chinese student, I have a question about the industry in China. So we know that the construction industry has a significant reduction recently. So my question is, do we have what's the research direction just for these changes for the industry recently?
Okay, yeah, the industry is a bit decline, but the research needs actually increased because the market squeeze means there's bigger competition, so that the contractors need to compete more for jobs. Then the technologies become very, very important. The advanced technologies may help them to win the job. So they invest more in researches. I think this is the AI related and the IoT related researches is the major trends. Because my field, my research has divided into two parts. Just now I mentioned about the urban resilience, and I have another part is for construction safety. And for this part, we tried our best to use the IT and the AI to enhance the quality and the effectiveness of our research. Try to support the industry's innovation in the future.
Thank you, Wei, for that question. Any other questions from the audience?
Hello, Professor Fang.
Yes.
Yeah. My name is Chang Yibo, and I'm a Chinese student, first year PhD student in Purdue, and I also graduated from Purdue and HKUST. So I have questions here about the nature, the urban resilience. As we know, our country experienced a very quick development in our infrastructure and our cities. So the human-centered measurement for our urban resilience is very interesting. I want to ask that if we have some effective way to improve the current urban resilience, because we experienced the basic level and now we are experiencing the advanced level.
Okay, I'll try to answer your question, although I didn't understand fully. But I think our cities exist few decades, few hundred years, even thousands years. So there's inherent resilience within all the cities we live, but the level can be different. So due to the climate change and the more disasters emerged, so every city also need to improve its resilience from the current level. So then we need to identify the best way to do it. That's why I talked about the cross system and cross-dimensional. All this work is to help the local government to invest in right infrastructure, right location, so that they can get the best benefit, because all the money are from the taxes, so they need to better use it. So this is what we do. So, but different cities may have different problems. So we cannot tell all the cities what infrastructure you should invest, what kind of infrastructure you need to strengthen. It's not the right way. So we need to look at all the cities' problems specifically and provide them the proposals. That's why we choose to use the curve. You know, if you look at the resilience, no matter the Arab indexes, the UN indexes, you will find that they are all purely index related. Mechanically it's not dynamic. It's static. It means there's only indexes there. You cannot tell at what stage of the disaster what kind of resources you need. But we are trying to avoid that way. So we are trying to make it a dynamic one, so that in any time of the stages, we can bring out our proposals to how to go the next step. Thank you.
If
I don't know if I answered your question or not.
Thank you, Professor. I got that.
Thank you, Xiang.
Thank you.
I think we have time for one more question. Anybody from the audience? Any pressing questions? Okay. Well, in that case, let me ask my question. I always take the last question. So,
Thank you.
Again, Professor Fang, very, very interesting presentation indeed. And so the question I have it has multiple parts to it. So I'll try to go through that. But in terms of interdependencies between the various agencies that need to respond to recovery post disaster, you did mention about interdependencies between different systems and so on. But my question is that in terms of interdependency, first of all, how are you identifying what role which agency needs to play in terms of recovery? So that's one. The second part of that is, at what level of granularity do you look at the available capacity and resources, given that different parts of the society or different parts of the urban environment might have different affluence or state of the infrastructure.
Mark, let me answer first of your question, and I may need you to repeat the second.
Sure,
Let
sure,
me answer your first question first. So this is the mess. You can see the screen, right?
Yeah.
This is the reason why we use the hypernetwork to model the scenarios, because the one of the very important the index in the hypernetwork is the hyper edge. This is I don't think I have time to explain to details, but you can see this is a 3-layer hypernetwork. These 3 layers. Can you see my mouse moving?
Yeah.
Okay.
Yeah.
These 3 layers represents the physical infrastructure, social services, and the human needs. The linkage of this called the hyper edge. The hyper edge linked with the people's needs, and what's the social infrastructure. For example, the transportation was not met, and then it's also linked back to the physical infrastructure. So by this way, we can identify one of the problems linked to how many social services and linked to how many physical infrastructures. So that the more links we have, not the more important the infrastructure is, so that we can request the government agency which is in charge of this infrastructure to take action.
Okay.
So I don't know if I make myself clear or not for your first question.
I think you might have already answered my second question, but just to clarify, my second part of my question was, and I think Wei or I think somebody else touched upon that different parts of the society in an urban environment would have different level of affluence, and perhaps also different level of robustness in the infrastructure. So the levels of damage are going to be different, and levels of recovery funds available are going to be different. So my question was, at what level of granularity do you identify the capacity needs?
Okay. This is what I think the advantage of the people-centric. We define all the functionalities based on the people's needs was met or not. No matter the current situation is how bad or how good. So if in a certain area, there's more claims on transportation, that means there's more problems. Even though that area is quite advanced, quite a rich area with better infrastructure, but it may, since they claimed more, it means they have more worse situations need to be settled. So this is also a good way to achieve the equality of the society by this way, because we don't care if it's rich families' needs or poor families' needs. As long as you have the needs, it means there's a demand to be met.
Yeah, yeah, and I think if I Xian's question earlier, I think he was also trying to refer to the social inequality and how that is being addressed
Right.
in improving resilience. But I think that is an excellent point to stop the seminar since we run out of time. There are a number of other questions that I had on my list, but perhaps I'll ask you those questions when we meet in person. But thank you again very much. I know that this is late for
Thank
you.
you for the invitation.
Yeah, thank you. We really
It's my
appreciate
real
it. So,
honor to attend your presidential seminar. Thank you, Mark.
thank you.
And
So,
thank you for all the audience.
So please give him a big round of applause. Please open your mics or, whichever way you like to do it. So
Okay.
thank you very much.
Thank you.
All the virtual claps, right? So with that said, everybody, thank you all for attending the seminar today. And stay tuned for the seminar next week. Next week, we're going to have Professor Lu Man Chang from National Taiwan University, who will be in person on campus. So please remember to come to the studio for the seminar. With that said, thank you all very much. And with that, I sign off for the seminar today. Have a nice day.